Welcome back to the deep dive. Our mission today is pretty laser focused. We're taking one very, very dense piece of hardware, the Aurora IPA-SFP-10G23C1 module. And we're going to translate all that technical shorthand into, actionable insights for you.
Exactly. I mean, when you look at that part number, you're looking at the heart of a professional, long-haul AV over IP solution.
Right.
This is a 10 gig SFP plus BIDI single-mode module, and it's built specifically for Aurora's IPX series. It's what lets data travel, 10 kilometers without even breaking a sweat.
Okay, let's unpack that right away. Let's start with those key specs. We all get 10 Gbps. That means blistering speed. You need it for uncompressed video. But let's talk SFP plus WIV. What does that plus really signify here?
Yeah, that plus is key. It's what officially designates the module for 10 Gbps speeds. The older SFP modules, they capped out at 1 Gbps, so this is a huge step up.
Oh, okay.
And it also uses a smaller form factor so you can pack more bandwidth into less physical space on your switch. It's really the go-to standard for any modern high-density network.
So we have the speed confirmed. And now let's get to the distance. I mean, most short-haul AV runs, you're using copper or multi-mode fiber, right? You're maxing out at, 300 meters?
Maybe.
On a good day.
And this module is promising 10 kilometers using single-mode fiber. Is Aurora sacrificing anything like resilience or cost to hit that kind of range?
That's the beautiful thing. What single-mode fiber gives you is the elimination of something called modal dispersion.
Okay.
Think of it this way. With multi-mode, the light signal sort of bounces off the inside walls of the fiber, and that causes distortion. It just kills your speed over distance.
Makes sense.
But single mode uses this incredibly narrow core that forces the light to go straight down the center. And that stability is exactly what makes that 10 kLm transmission possible without losing any signal quality.
And here's where it gets really clever, I think. The bidirectional part. The BIDI architecture. It's not just that it goes far, it's so efficient. Most fiber runs need 2 strands, right? One to send, one to receive.
Right, and BIDI cuts that physical cabling in half.
Which is a huge deal.
It's a massive cost saver on the install. The way it works is, it's just physics. The module uses 2 totally separate wavelengths of light, 1270 nanometers to send and 1330 to receive. And it does both at the same time over that one single fiber strand.
So you're doubling your fiber utilization.
Exactly. Now, the key thing to remember, and you have to get this right, is that this module, the 23C1, it has to be paired with the complementary IPA-SFP-10G23C1 module at the other end to complete the link.
Got it. Okay, so the tech is lightning fast, it's incredibly efficient, but, speed only matters if you can actually get it and deploy it.
Yeah.
Let's totally switch gears and talk about the logistical side of things, like compliance. This module is listed as TAA compliant, and it's advertised as tariff-free. What does that actually mean for an installer?
This is a massive distinction. Huge. Especially for anyone working on larger contracts. So TAA is the Trade Agreements Act. What that means is the module has to be manufactured or substantially transformed in the U.S. or a designated friendly country.
Okay, so it's not just a box to check for federal jobs. It's really about sourcing, transparency, and eligibility for sensitive projects.
Precisely. If you are bidding on a government project, federal, state, whatever, TAA compliance is often a hard requirement. It literally determines whether you're even allowed to use this component.
And that ties into the budget, right, with the tariff-free part?
Yes. That translates directly into a more cost-efficient solution for you. It frees up budget for other parts of the system. We can see the price right now is $498, and there's even a 10% discount with the code 10% off. That commercial angle, it really matters just as much as the tech specs.
And that brings us to the end of our dive. We basically took a dense part number and we unpacked it. It's a story about speed, distance, efficiency, and the logistics that make it all possible.
Right. We hear the tech and the commercial viability. There's a final thought for you to chew on. The next time you design a 10 gig network, ask yourself this. Is your biggest bottleneck the physics, the distance the light can travel, which this module solves with 10 kOM? Or is it the bureaucracy, that TAA compliance, that ultimately determines if you can even buy the thing in the first place? That balance between optical power and paperwork, well, that's what really defines professional AV over IP today.